Hey there, Mr. Sutton here, bringing you the Pre-Cal Honors 4-4 Extra Practice Solutions on Laws of Logarithms. For this problem, we're trying to expand this logarithm. Since we have division, we're going to split that up into two logs using subtraction. So we'll have log base 4 of 5 to the 6th minus log base 4 of 2 to the 5th. Next, we're going to get rid of these exponents by popping them out in front as multipliers. So this first one's going to become 5 log base 4 of, or rather 6 log base 4 of 5, minus, this will be 5 out in front, log base 4 of 2. For this problem, I'm trying to expand this logarithm. This ln, that's really log base e, so it follows all the regular rules of logarithms. I'm going to start by rewriting this as ln of w times u to the 1/2 times v to the 1/2. I can distribute that square rooting amongst the factors in here. Now I'm going to split this up into 3 logarithms. And since all of these terms are being multiplied, I'm going to split this up using addition of logs. So I'm going to have ln of w plus ln of u to the 1/2 plus ln of v to the 1/2. And next, I just have to pop out those 1/2s out in front as multipliers. So I've got ln of w plus 1/2 ln of u plus 1/2 ln of v. For this problem, I'm trying to expand this logarithm. So since I'm multiplying the things inside this logarithm, I can split that up using addition of logs. So I'll rewrite this as log base 6 of 2 plus log base 6 of 3 plus log base 6 of 5 to the 6th. And then the only thing I need to do at this point is pop out that 6 for the exponent out in front as a multiplier. So I've got these first 2 logs unchanged. For this last one, I'll rewrite this as 6 log base 6 of 5. To expand this logarithm, I'm going to split up this division using subtraction of logarithms. So I'll have log base 7 of 11 to the 3rd minus log base 7 of 10 squared. And then I'll pop out those exponents as multipliers. So we've got 3 log base 7 of 11 minus 2 log base 7 of 10. For this problem, I need to condense this expression to a single logarithm. I'll start by popping in any multipliers as exponents. So this first thing I'll rewrite as log base 7 of 10 to the 10 plus log base 7 of 3 squared. And next, since I'm adding logarithms, that means I multiply the expressions inside together if I want to turn this into one big log. So I'll have log base 7 of 10 to the 10 times 3 squared. To condense these expressions into a single log, I'll start by popping in multipliers as exponents. So this first log I'll rewrite as log base 6 of u cubed. Then we'll have minus log base 6 of v to the 6th power. Next, since I'm subtracting logarithms, that means I can divide their arguments. So I'll have log base 6 of u cubed divided by v to the 6th, all inside one big log. To condense all of these into a single log, I'm going to start by popping in multipliers as exponents. Now these are all being multiplied, if you think about it, by 1/3, which means that when I pop that in, I'm really going to have the cube root if that becomes an exponent. So this first one will be log base 3 of cube root of 7 plus log base 3 cube root of 5. Finally, plus log base 3 cube root of 8. Now I know the cube root of 8 is 2, and it's tempting to turn that into a 2, but since these other ones are cube roots, I'm going to leave this as a cube root just in case I still need it in that form. Next, since I'm adding these logs together, that means I can multiply their arguments together. So I'm going to have log base 3 of cube root of 3, or cube root of 7 rather, times cube root of 5 times cube root of 8. Since these are all cube roots, I can merge all of these inside the logarithm into one big cube root with 7 times 5 times 8 inside the cube root. So this is just using the rules of radicals along with the rules of logarithms. Next, let me go ahead and actually just simplify that. So you can multiply these in any order. For example, 5 times 8 is 40, and 7 times 40 is 280. So if I want to, I can make this log base 3 of cube root of 280. To merge these into a single log, let me start by popping in these multipliers as exponents. So I've got log base 8 of x to the 6th plus log base 8 of y squared. Adding the logs means multiplying the arguments. So this is really log base 8 of x to the 6th times y squared, all inside one big logarithm. To merge these into a single log, let me start by popping in those multipliers as exponents. So I've got log base 4 of x to the 6th minus log base 4 of y to the 36th power. Since I'm subtracting logs, that means I'm really dividing the things inside if I merge these all together. So this will be log base 4 of x to the 6th divided by y to the 36th, all inside one big log. To merge these into a single log, let me start by popping in multipliers and divisors as exponents. So these divided by 2's, these are really multiplying by 1/2. If I pop that in as an exponent here, I'm really square rooting whatever's inside. So I've got log base 7 of w, which doesn't need to change, plus log base 7 of square root of u, plus log base 7 of square root of v. Adding these logs together means I can multiply the things that are inside of them. So this is going to be log base 7 of, and now big parentheses, w times, now if I multiply these two roots together, I can merge them into a single radical. So we have w times square root of uv, and that again is all inside one big log.